All right, on page 244 is where this one starts. Again, we're going to do this over 2 days. So first thing that I'm going to go through with you guys is not new information. First thing I'm going to review with you guys is the properties of exponents. Some things that you guys may or may not have forgot along the way. First of all, when you have a product, when you have a to the m times a to the n, what do you do with the exponents when you're multiplying? Add them, right? So a to the m plus n. So when you're multiplying like bases together, you add the exponents. That's not new. We've already done that this year. You remember when we had to FOIL everything out, we were actually doing that rule. X times x was x squared. You added 1 plus 1 to make 2. Good job. Then, the power rule is where you have a to the m raised to the n. Does anybody remember what the shortcut is for that? What do you do with the exponents in this situation? Huh? Multiply them, right. The alternative would be, and I'll show you ones that actually have numbers here in a little bit. The alternative would be write it out that many times so that you're multiplying it, and then you add exponents, and then you get the same answer if you would have just multiplied it. So that's a little bit of a shortcut. So the product rule is where you add them. Power rule is where you multiply them. A lot of people get these two confused. Okay, these two are two important ones. If you have two pieces of info inside parentheses, this is called a product on the inside, and you're raising it to a power, what do? Huh? Multiply what?
The two on the inside together.
If you could multiply the two insides together, that would be okay, and then raise it to that power. But what if they're like, one's a 3 and one's a x? And you don't know what x is, right? Does anybody remember the trick to doing this one, though? Not divided. What? Put m on a and b. When you have power to a product, what I decided to do, or how I word it is, it's basically like this. The m gets distributed into each of the exponents. Does that make sense? When I say distributed, do you guys understand what I mean?
Yeah.
If I'm dishing it out? Okay. The next property. We talked about this one last week. What do you do with negative exponents?
Put them under 1.
Put them under 1 or vice versa, right? If it's on the bottom, you bring it up, and if it's on the top, you bring it down. Okay. So their scenario that they have is a to the negative m equals 1 over a to the m. Okay, so again, if it's on the top, you bring it down. If it's on the bottom, you bring it up. And that takes away the negative. Does anybody know what the 0 exponent does? Nope. Anything to the 0 power is always not 0. 1. There's a reason for that, and I'll show that to you here in just a second why. But the 0 exponent is always equal to 1. The quotient. If you have a to the m over a to the n, what's the rule when they're divided? You subtract the exponents. That's kind of the unwritten rule. Now, there's a catch to this. And this is what I mean by the catch to it. If I had like bases, one on the top, one on the bottom, if I subtract them, that's awesome and that's the answer, but then there could be a potential of giving you a negative exponent. What happens? Can you leave it as a negative exponent? No. Then you got to move it back downstairs. So when it comes to the quotient rule for me, and I'll show you guys this here in a little bit, but when it comes to the quotient rule for me is, I don't treat the quotient rule the way it's written. What I will do is I will look at who has more, the top or the bottom. I'm still going to subtract them. However, I'm going to keep the answer whether the top has more or the bottom has more in the top or the bottom, depending. So if I had like x to the 7th on the top and x to the 10th on the bottom, who has more, top or bottom? The bottom. By how many? 3. So I keep my answer in the bottom, but I just subtracted the numbers instead of having to deal with the negative exponent. Okay? So, and the last one, power to quotient. Allie just talked about this one a little bit ago when she said to put the m into each of them when it was product. So what's quotient? Is it the same concept? Yes. Do you know why it's the same concept? Does anybody know what the definition of division is? The definition of division is multiply by its reciprocal. So in the definition of division, you're actually multiplying. So therefore, are they the same properties? Yes. Okay? All this is not new information. This should have been something that you guys would have had in Algebra 1. The only difference is, we're not necessarily going to be dealing with whole numbers. Okay? That's the catch. So, if I had something like 7 to the 1/4 times 7 to the 1/2. First thing I look at is, are the bases the same? Yes, they're both 7s. If you're multiplying, what do you do with the exponents? Add them. What's 1/2 plus 1/4? 3/4. How did you get 3/4?
Because 1/2 is 2.
Okay, if you make them common denominators, 1/2 is really 2/4. And when you add, this is a big mistake for a lot of people, when you add fractions together, make sure the bottoms are the same, and then you add the tops and keep the bottom the same. A lot of people will tell me that that answer is 3/8. They added the bottoms also. Not the case. You just add the tops. 6 to the 1/2 times 4 to 1/3 squared. How do I simplify this? Which is the directions, by the way. I do not multiply 6 times 4 because I have different exponents. I distribute the 2 exponent into both of them. Absolutely. What is 1/2 times 2? 1. So 6 to the 1st times 4 to the, what's 1/3 times 2? 2 6, which reduces down to 1/3. No. Okay, stop. Back up the train. Don't listen to Sarah. You said 2 6. Right. Right.
Yes.
When you take 1/3 times 2, it's 1 times 2 is 2. 3 times 1 is 3, because this is like over 1. Okay? You said 2 6, didn't you? Oh, yeah. Whatever.
Just said it himself. He's like, yes.
That's it. Then how do we do one that's 9 to the 2nd? That's
Do we not
just like what we
simplify
did.
That's, what else can you do? The reason, okay, here's the question. The question Allie said was, can you do anything further with it? Now think about what we did on Friday. This would be the 4th root, or the 3rd root, of 4 squared. That's really what that number is. That's a square root, right? Times 6. Is there anything that you can't multiply inside and outside together? unless they're the same base.
No, I'm thinking like adding 1 and 2/3 together.
Oh, but they're not the
But
same base.
Yeah.
If they were both 6s or both 4s, yes, but they're not.
Oh, wait, you can only add with the same choice?
Yep. Are you guys okay with stuff like this so far? Okay. Then, the next concept.
Look at the questions.
Another product property, but this time it's dealing with radicals. If you have two things multiplied together underneath the house, if you need to, you can split them up and be the nth root of A times the nth root of B, and vice versa. Okay? So if I had two things being multiplied that had the same number in the crack, I could actually multiply the two underneath pieces. So if I had the cube root of 2 times the cube root of 3, I'd have the cube root of 6. Because 2 times 3 is 6. Okay? And then the other one, the quotient property. Is very similar. The only difference is we're dealing with division. I can split it up into two different pieces if I have to. Or, if it is two different pieces, you can make it in one. So something like that. Like the first one. If I had the cube root of 4 times the cube root of 2, the cube root of 4 does not come out evenly, nor does the cube root of 2. But do you notice how the crack is the same? Yes. So what is 4 times 2? That's really the cube root of 8. If you have the same crack number, you can then multiply the inside pieces together also. So 4 times 2 is 8. Now, what's the cube root of 8? 2. That does simplify all the way down to a whole number. The individual pieces themselves did not, but when you combine them, it does. Does that make sense? Then, one like that also would be the 4th root of 80 divided by the 4th root of 5. Now, just so that you guys are aware of it, the 4th root of 80 does not reduce evenly, nor does the 4th root of 5. So therefore, if it's division and they have the same crack number, instead of writing it like that, I could do one big house with 2 stories. And what's 80 divided by 5? So now I end up with trying to break down the 4th root of 16. Does anybody know what the 4th root of 16 is? 2. Okay? So that's how those properties can help you. That's how they can work. Then, a couple different things that they talk about on the middle of page 245. When they talk about simplest form. There's 3 different criteria when it comes to simplest form when it comes to radicals. First thing, no radicals. Have perfect nth root, or nth power, sorry, not root. As factors other than 1. that just means this, you guys, in layman's terms. In the last two examples I gave you, when I said the cube root of 8, we can't leave it as the cube root of 8. We have to reduce it down to 2 if we can. Cube or fourth root of 16, can't leave it as that. We gotta get it down to 2 if we can. That's what that statement says. Okay. The next one. No radicals can contain fractions. And the third one, which is probably the one that is most important, no radicals appear in the denominator of a fraction. So what that means, you guys, is I cannot have a square root, fourth root, cube root, whatever, in the bottom. That can't happen. Okay? So using that, the next part of the examples, what they're going to do is now they're going to go through and just give you a couple of them to help simplify. This is very similar to what we did on Friday for most of these. They're just trying to get you to reduce. And it goes back to the question Sarah asked on the previous assignment, what if there's leftovers? And you noticed on the assignment there was no leftovers when you reduced them. Now there will be. Okay? If I gave you the cube root of 135, and I asked you again, it just says simplify. So here's what I'm going to do. I'm going to reduce or break down the 135 just like I have all the other ones. Does 2 go into 135? No. Does 3? Yes. How many times? 45? Does 3 go into 45? Yes. How many times? 15. Does 3 go into 15? Yes. How many times? 5. Does 3 go into 5? Does 5 go into 5? Yes. Now, when I have a cube root, I'm looking for 3 of the same number. Do I have 3 of the same number? What number is there 3 of? 3. That goes on the outside. Anything that I didn't circle has to stay underneath. What number needs to stay underneath? 5. Now the only difference is, when we did this in square root land a long time ago, we just had square root, not cube root. What if it would have said, by the way, fourth root of 135? Would there be 4 of the same number? For this problem, would there have been 4 of the same numbers? No, there would have been 4 numbers, but not all the same. So then it would have stayed as the fourth root of 135. Okay? Then another type. Cube root of 7 over the cube root of 8. Or not cube root. Let's change that. Not cube. So you want 4 or 5? 4? Okay. All right, first thing that I'm going to do when I'm doing this is I'm going to say to myself, self, does the fourth root of 8 reduce? If I put them together into one fraction, can 7 divide by 8? No. Shoot. So now it's time to simplify it, and this goes back to the fraction. Can you have a radical or square root house on the bottom of a fraction? No. Sorry. So how do you get rid of it? You multiply it. Okay, now, there's a couple different ways of doing it, but I'm going to try to make it as simple as possible for you. The numbers are going to get big, but I think you'll be okay. If the number in your crack is a 4, that means you need to have 4 total things on the bottom. How many do you have right now? You have 1 in the bottom. There's 1 4th root of 8. And you need to have how many? 4. Why did I know that I needed 4? Because it's a 4th root. If it would have been 5th root, I would have needed 5 of them. 6th root, I would have needed 6 of them. So if I need 4 and I already have 1, how many more do I need? 3. 4th root of 8. 4th root of 8. 4th root of 8. I needed 4 total because the number in my crack was a 4. If my number would have been a 3, then I would only need 3 of them. 5, 5 of them, and so on. Does that make sense? Now, quick question for you about fractions. If you do something on the bottom, then you got to do it to the top, which means 4th root of 8, 4th root of 8, 4th root of 8. When you have the 4th root of 8 4 times, I do not expect you to multiply that number out. Because 8 times 8 is 64, times 8 is blah, 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 times 8 again is a ginormous number. To 4th root that one, you'll just get 8. How did I know I was just going to get 8? How many 8s are there on the bottom? 4 of them. If I rewrote it to be like this, that would be the 4th root of 8 to the 4th. And when you have this number matching this number, they cancel each other out. And what number would I have left in the bottom? 8. If you do it right, what number should remain in the bottom? Whatever's underneath the house. Okay? Now, here's where it's going to get big. But I'm going to show you a trick with it. I don't physically want to know what the number 7 times 8 times 8 times 8 is, because that's what I would have to do. That's a big number. All right? I'm going to help you out a little bit with this. How many 7s are there? 1. What number does 8 reduce down to? 2 to the 3rd. That's 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Or the 4th root of 7 times 2 to the... What do I do with the exponents when you're multiplying? Add them. What's 3 plus 3 plus 3? 9. I have 9 2's in my hand, and I'm looking for groups of 4. How many groups of 4 can I make?
2.
Where does this one go? Center underneath the house. Right. So you told me I had 2 2's. Right? 2 2's? So what's 2 times 2? 4. That goes on the outside. You said I had 1 2 left over, but there's also that 7 guy. What's 2 times 7? 14. All over 8. Now the only thing you have left to do is you have to simplify if there's anything on the outside that reduces with the bottom. The inside number cannot be touched. You are inside the house. You're in the safe zone. 4 and 8 can reduce down to what? 1/2. So my final answer for that is the 4th root of 14 over 2. And the last new one looks like this. We just talked about it. We cannot have square root house on the bottom. But this one's unique. The reason why it's unique is because we have 5 plus root 3. It's not just root 3 down there. So if you have 5 plus root 3, what you need to do is you need to multiply it by its conjugate. Do you remember that word? We talked about it last chapter. What's the conjugate of 5 plus root 3? Yay! And if you do something to the bottom, you gotta do it on top. Right. So this becomes FOIL. And which part would you like to do first? The top or the bottom? Bottom? Now, here's what doesn't happen. And hopefully you guys caught on to this before. And I know I talked about it, but sometimes you forget. When you multiply conjugates together, does it all go away? No. What's 5 times 5? 25. What's 5 times negative root 3? What's root 3 times 5? Now here's the $1 million question. What's root 3 times negative root 3? Negative the square root of 9, which is just 3, right? On the top, what is 1 times 5 minus root 3? What happens with those two parts? They cancel each other out. When you multiply conjugates together correctly, what should happen? Those two pieces should go away if you do it right. On the top, nothing's changed. But on the bottom, what's 25 minus 3? 22. And done. Here's what happens to most people, not only in high school, but also in my college classes. When I multiply conjugates together, it does not go away. Okay? The middle terms of O and I part of FOIL go away, not the rest of it. And that's what happens. A lot of people think the entire thing just goes bye-bye. Not so much. Okay? So you're going to have a little bit of each of all those example ones that we just did. It starts on page 248 and goes 3 to 36, multiples of 3. Now on 3 through 12, it says use the properties of exponents to simplify the expression. So depending on whatever property it's showing, simplify it. 13 through 20 says use the properties of radicals to simplify it. So if it shows multiplication, I would multiply the insides together, then reduce it. If it shows division, maybe do it the other way. On 21 to 28, it says write the expression in simplest form, which is like the third ones I did. And then 29 to 36, write the expression in simplest form. That was just like the conjugate one we just did. Okay?